Good afternoon. My name is Hassan Sukaran. My metric number is MA240450. Introduction. In engineering, analyzing and evaluating static structure is crucial to ensuring safety, functionality, and durability across various applications. Static structure which are stationary and experience load with significant motion are commonly found in industrial, commercial, and residential settings. Today, I focus on wall-mounted metallic shelf-like structure as shown as Figure 1. We explore its design purpose, and static challenges associations with it.
Okay, my name is Shaman Anagasundramurthy and my matrix number is MA24088, and today I want to talk about the function of the structure. The structure is a wall mounted metallic shelf which is designed for lightweight storage, and the primary functions are to secure space for tools and for raise the panels, prevent items from falling out of the sides. Okay, for the static problem we're going to look about uh, stress consideration, which is load distribution, which may create or cause stress at the mounting points, potentially weakening all the brackets over time. And for the second point, uneven loading, which can lead to torsion or bending moment, compromising the shelf stability. And for the third one, material deformation, which can make a risk of deformation if the shelf is subjected to a loads beyond its design availability. And for the last one is environmental factors, which are corrosion or wear over time, which can reduce structural integrity. And there are some of the recommendation for improvement, uh, where we can use high quality materials to enhance durability and load bearing capacity. And the second point is ensure proper evaluation of load distribution during design. And for the last one, incorporate protective coatings or corrosion resistant material to mitigate environmental damage, which we can paint any metallic paints which can prevent it from corrosion. That's all from me. Thank you.
Right, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Shafdi bin Ahmad Daud with matrix number MA24107. Now for rigid body equilibrium. Okay, for equilibrium, the following condition must be satisfied, which is the sum of the component Fx must equal to 0 and the sum of the component Fy must also equal to 0 and the sum of the momentum also must be equal to 0. And this is the dimension of the shaft from the side, as you can see in the image above. Now I will show you the calculation that we use in the rigid body diagram, as you can see at my side. Okay, first we need to convert the force acting downward, which is the weight, into Newton. Then as you can see, 50 will times by 9.81, and then we can get 147.15 Newton. And then with using the equation AX plus BX minus weight equal to 0, we can get that the sum of the moment also equal to 0. Then we can substitute the numbers into the equation Bx times length minus in bracket weight times length divided by 2, as you can see in the equation. Okay, then we can get the Bx equal to 7.6 Newton. Then after that, we can substitute the Bx into the vertical force equation, the same question that we use, which is the Ax plus Bx minus weight equal to 0, and then we can get the Ax. Like our calculation here, our Ax is the equal to 142.79 Newton. And then as the result, we can get the reaction at the upper support, which is the component Ax, equal to 7.6 Newton, and the reaction at the lower support, which is at the component Bx, equal to 142.79 Newton. Alright, that's all from me.
Thank you, Darwish. Hello, my name is Mohammad Hafiz Zafran, student code MA24109, and I will now explain the last part of the presentation, which is the centroid of the metal shelf. And from the side view of the metal shelf, we can create a free body diagram with the dimensions needed to calculate the centroid. And here is the picture of a free body diagram. Before we start to calculate the centroid of the shelf, we will need to refer to these formulas so we can find the area, center of X, and the center of Y for all the segments involved. After we calculate all the values needed to find the centroid, I will present them in the table form right here, so it is more systematic and easier for you guys to understand. Now we can find the centroid of the mounted shelf by using the formulas, thus getting 0.0925 meters for coordinate X and 0.0307 meters for the coordinate Y.
In the planning stage, we address all the key questions about the project. For the structure weight, we use the formula W equals to mg and calculated value is 147.15 newtons. The free body diagram clearly shows all the measurements and forces acting on the structure. To analyze rigid body equilibrium, we calculated all the forces by assuming that the net forces and moments are zero. Lastly, the center of gravity, we determined the coordinate of the structure weight center is 0.00925 meter for the x coordinate and 0.0307 millimeter for the y coordinate.